Teacher Nev and welcome back to our general math class. In this video lesson, we will focus on the visual representation of a logarithmic function or how its graph looks like in a Cartesian plane. Let's start. In studying the graphs of logarithmic functions, it's good to relate them to their corresponding equations. So first, let us take note that the basic function f of x equals logarithm of x to the base b can be transformed to a more complex one, f of x equals a times logarithm of x minus c to the base b plus d, where b is positive except for 0. Aside from that, b can be grouped into two. b is greater than 1 and b is greater than 0 but less than 1. The factor a, on the other hand, is responsible for doubling or tripling or increasing or even decreasing the value of the logarithm since it multiplies the logarithm by its value. It can also be negative, thereby making the value of the logarithm negative. The factor c, meanwhile, affects x in such a way that it adds or subtracts units to x before finding the value of the logarithm. Lastly, the factor t affects f of x or y in such a way that it adds or subtracts units to the logarithm.
Example 1. Sketch the graph of f of x equals logarithm of x to the base 2 and describe its properties. In order to sketch the graph of any equation, we need first to prepare a table of values for x and y. So this is the table of values for this equation. We'll assign first values to x, as we have learned from the previous lesson, especially in solving logarithmic inequalities. The anti-logarithm is always positive. Since the anti-logarithm in this equation or function is x, then we have to see to it that the x values are all positive numbers. The numbers that we assign to it are all positive numbers. So since that x can only be positive and it cannot be negative nor 0, then we also have to take into consideration the values of x, positive values of x, as x gets closer and closer to 0 from the right of x. So those are 1/2, 1/4, 1/8, 1/16, and you may also consider other x values closer and closer to 0. Okay. When you substitute every value of x to this equation, you'll know the value of y, and these are the corresponding y values. Okay, let us now sketch the graph. So this is the graph of the given function when you try to plot the points from the table of values in the first slide. So this is the curve that you will form, which is the graph of f of x equals logarithm of x to the base 2. So let us now describe the properties of the graph of this equation or function. So given f of x in the form f of x equals logarithm of x to the base b, where a is equal to 0, c equals 0, and d equals 0, the graph for sure is increasing. It is increasing from left to right. The domain or the set of x values is the set of positive real numbers. X cannot be 0 or any negative number, so it can only be positive. That can be reflected or can be seen from the graph. The x values of every point consisting this curve are all positive numbers. So the domain is the set of positive real numbers. The range, however, is the set of real numbers. There are y values, the y coordinates of these points are positive, this part of the graph. Then we also have a point in the graph with the y-coordinate 0 as well as y-coordinates negative. So the y values or the range as a group is the set of real numbers. The x-intercept is positive 1 because this point is 1, 0. So that means the graph intersects the x-axis at positive 1, and that's the x-intercept. However, there is no y-intercept because the graph does not intersect the y-axis. So there is no y-intercept. Then the vertical asymptote is x equals 0. This line, which coincides with the y-axis, acts as the vertical asymptote. And we know that the equation of that line is x equals 0. That x equals 0 is the line which the graph approaches and approaches from its right. But it will never intersect, even how far we extend the graph. Next, there is no horizontal asymptote because this will continuously decrease and this part of the graph will increase infinitely. So there will be no horizontal line which the graph will approach and approach but will not intersect. So there is no horizontal asymptote. Example 2. Sketch the graph of f of x equals logarithm of x to the base 2 and f of x equals logarithm of x to the base 1/2. Describe their properties. This time we have two given functions, and if you notice, the first function has been graphed already in example 1. And actually, this is the table of values which we have prepared for the first equation in example 1. And for the second equation or function, if you notice, we use the same set of x values, all positive. And for the y values, of course, this will be known by substituting each x value to this equation. These are the graphs of the two functions in example 2. The blue graph being the graph of f of x equals logarithm of x to the base 2. We have seen this already in example 1. And for the second graph, it is the purple curve. That is f of x equals logarithm of x to the base 1/2. So they are different. And let us look at or describe their properties. Given f of x equals logarithm of x to the base b, again, that is f of x equals logarithm of x to the base b. Notice that each of the given functions is written in this form, where b or b in the first equation is 2, and in the second equation it's 1/2. In general, the graph of f of x equals logarithm of x to the base b is increasing if that b is greater than 1. So that is why the blue curve is increasing, because the b value here is greater than 1, that is 2. And it is decreasing if b is greater than 0 but less than 1/2, meaning between 0 and 1. And that is true to the purple graph, where the value of b is 1/2. It's between 0 and 1. It is decreasing. Next, the domain in both equations, where b is greater than 1 and b is greater than 0 but less than 1, the domain is the set of positive real numbers. By just merely looking at the graphs, we can see that the x-coordinates of the points consisting them are only positive numbers. They cannot be 0 nor any negative number. And for the range, it is the set of real numbers. Any y value can be part of the graph or can be a y-coordinate in the graph. So y can take positive, 0, or negative numbers. So it is the set of real numbers. That's for the range. Then the x-intercept is 1. As a matter of fact, they intersect at that point, at 1, 0. Both touch the x-axis at 1. So the x-intercept of both functions, where b is greater than 1 or b is between 0 and 1, is always 1. Then there is no y-intercept because both do not touch the y-axis, so there is no y-intercept. The vertical asymptote is x equals 0. Aside from the graph does not touch the y-axis, the graph gets closer, each of the graphs gets closer and closer to y-axis. Also the blue graph, it gets closer and closer to the y-axis, but it does not touch nor meet the y-axis. So that means the y-axis, or the line which coincides with the y-axis with an equation x equals 0, is the vertical asymptote. And of course, there is no horizontal asymptote, just like what we said in example 1. Example 3. Sketch the graphs of f of x equals logarithm of x to the base 2, f of x equals 2 times logarithm of x to the base 2, and f of x equals 1/2 times logarithm of x to the base 2. Then describe their properties. So example 3 has 3 functions. We already have sketched the graph and prepared the table of values for the first function, and this is that. Now for the second function, it's also like the first function. The only difference is that the factor before it is 1, while the second function is 2. So from 1 it became 2. How will it affect the table of values? So we assigned to x the same set of x values as with the first table of values, and then we compute for the corresponding y values. And then for the third function, when we make 1 1/2, this is what will happen with the table of values. For us to clearly describe their properties and compare and contrast them, let us sketch their graphs. These are the graphs of the functions in example 3. The blue curve is familiar to us already because we've been talking about f of x equals logarithm of x to the base 2 from example 1 and example 2 also. And then when we double the value of each of the logarithm, or when we make the value of a 2, this is how the graph will look like, the purple curve. And when the value of a is 1/2, or the other factor before logarithm, that is when we divide this logarithm by 2, or when we get 1/2 of this logarithm, this is how the graph will look like, from blue curve to gray curve. Okay, let us now describe their properties. Given f of x equals a times logarithm of x to the base b, for sure, the graph is increasing if a is greater than 0. Okay, going back, a here is 1. That's greater than 0. A here is 2, which is also greater than 0. And of course, 1/2 is also greater than 0. So that is why each of these graphs is increasing. Next, the domain is the set of positive real numbers. We can clearly see from this Cartesian plane that each of the graphs do not touch the y-axis, or we do not have any part of the graphs in the third quadrant, nor in the second quadrant and in the third quadrant, meaning there are no points in the graphs, in each of the graphs, with x coordinates negative, or negative x coordinates. So again, the domain, or the x values, can only be positive. Then the range, or the y values, is the set of real numbers. For each of the function, the y values can be negative. There is a part of the graph in the fourth quadrant. Then it can also be 0. There are y coordinates, or there are points. There is a point for each of the graph with y coordinate 0. And there are points with y coordinates, or with positive y coordinates. So the y values can take any number. So the range is a set of real numbers. Then for each graph, we can notice that the x-intercept is 1. That's why that is their common point, 1, 0. Each of the graphs touches the x-axis at 1, so the x-intercept is 1. And there is no y-intercept because as we've mentioned, they do not touch the y-axis, so there is no y-intercept. And the vertical asymptote is x equals 0 because aside from not touching the y-axis, the graphs gets closer and closer to it. If we zoom this in, we will notice that they get closer and closer to the y-axis, but they do not intersect it. So the line coinciding this y-axis with the equation x equals 0 is the vertical asymptote. And there is no horizontal asymptote. We've explained this from example 1 already. And the distinguishable property of this is that the graph is shrinked as a decrease in value and it is stretched as a increase in value. Notice from 1, when it became 2, the value of x there increased, the graph is stretched from blue to purple. And from 1 to 1/2, where the value of a decreased, the graph is shrinked from blue to gray. Example 4. Sketch the graphs of f of x equals logarithm of x to the base 2 and f of x equals negative logarithm of x to the base 2. Describe their properties. So this time, what is different between the given graphs or given equations is the value of a. A here is positive and a here is negative. In example 3, we have 3 different positive a values. Here in example 4, we have a positive and we have a negative a value. Okay, let us sketch their graphs and describe their properties. Again, we begin with preparing a table of values, and this is the table of values again for f of x equals logarithm of x to the base 2. For the second equation, where a is negative 1 to be exact, that's negative 1 times logarithm. We assign the same x values to x, and then we compute for the corresponding y values. And this is what happens. Notice that each is the negative of the first set of y values. Let us see how this will look like in the Cartesian plane. Okay, these are the graphs of the functions in example 4. Again, the blue curve is for f of x equals logarithm of x to the base 2. That is when a is positive, and when a is negative, the graph looks like this, the purple curve. Okay, what are their properties? Given f of x equals a times logarithm of x to the base b, the graph is decreasing if a is less than 0. A here is less than 0 because it's a negative number. So that explains why the purple curve is decreasing. Because it will always be decreasing if a is less than 0. But if you still recall in example 3, we have learned that if a is greater than 0, meaning if it is positive, the graph is always increasing. Next, the graph of the logarithm with a negative, so just like this equation, it is symmetric to f of x equals a times logarithm of x to the base b, where a is positive with respect to the x-axis. So with respect to this axis, to the horizontal axis or x-axis, the graph of the logarithm with a negative, with a negative a, is always symmetric to its counterpart logarithm when a is positive. From positive 1, or let us mention this first. From negative 1, it became positive here, or from positive 1, it became negative 1. For sure, their graphs are symmetric with respect to the x-axis. And we can clearly see that from these graphs or Cartesian plane. Next, the domain is the set of positive real numbers. So even if a is negative, still the x values are positive. And still the range is a set of real numbers. So the y values still can take positive numbers, 0 and negative numbers. We are talking about the y coordinates of the points composing the graph. Then the x-intercept is still 1, even if a is negative, it's still 1. Still, there is no y-intercept, and the vertical asymptote is still x equals 0. Because like the blue curve, the purple curve with a negative a approaches 0 or the y-axis, but it does not touch it. So that means the equation, the line x equals 0, which coincides with the y-axis, still is the vertical asymptote. And there is no horizontal asymptote also. Example 5. Sketch the graphs of f of x equals logarithm of x to the base 2, f of x equals logarithm of the binomial x plus 1 to the base 2, and f of x equals logarithm of the binomial x minus 1 to the base 2. Describe their properties. So this time, all a's are 1, all b's are 2, but the value of c are different. Values of c are different. For the first equation, we have 0. For the second equation, it is negative 1 because this comes from the standard form x minus c. So a here is not positive 1. That is negative 1. And a here is positive 1. Okay, let us prepare again a table of values. So this again is a table of values for f of x equals logarithm of x to the base 2. For the second equation, where c is negative 1, so we assign different values to x because x here can be negative, can be 0. If you try substituting 0 to x, it will work. There will be a y value. And even if x is negative, there will still be, for some negative values, there will be a corresponding y value. So we tried that for this table. And then for the third function, you will notice if you substitute different numbers to x, you will notice that it cannot be 0 nor any negative number. And it also cannot be 1. If you substitute 1 to it, there will be no value. So we consider this x values and we compute for their corresponding or respective y values. So these are the graphs of the three functions in example 5. Again, the blue curve is for our f of x equals logarithm of x to the base 2. That is when c is equal to 0. Now, when c becomes negative 1, why negative 1 again? Because this comes from the standard form x minus c. So that means positive 1 is also minus negative 1. So c is negative 1. And if c is negative 1, the graph will look like this, or the curve, the purple curve. And when c is positive 1, why positive again? Because this is x minus c, so this is also x minus positive 1. So c is positive 1. The graph looks like the gray curve. Okay, let us describe their properties. Given f of x equals logarithm of the binomial x minus c to the base b, the graph for sure is increasing. So that is why each of these graphs, purple, blue, and gray, is increasing. From left to right, it is increasing. It goes up. And then the curve is shifted to the left by c units if c is negative, and to the right if c is positive. In which graph is c negative? In the purple curve, because c here is negative. From this property, that means the graph from the blue curve, it is shifted to the left by 1 unit. Because c is negative. If it is negative, the shift will be to the left. So that explains why the x-intercept 1 becomes 0 when c is negative 1. And then since c here is positive 1, then we expect that every point will be shifted to the right by 1 unit. So that explains from x-intercept 1, it becomes positive 2. Next, the domain is defined by this inequality, x is greater than c. This time, for the first time, the domain is not just the set of positive real numbers. Now, the domain depends on the value of c because it is defined by x is greater than c, whatever the value of c is. So, since c here in our equation, in the first equation is 0, that means the domain is x is greater than 0. Or in other words, that's any positive real number. But since c here is negative 1, then the domain is x is greater than negative 1. So that means it cannot be negative 1, but all numbers to the right of negative 1 can be value of x. So that is why there is a part of the graph in the third quadrant, or those points with negative x values. And for the gray curve, since the value of c is positive 1, then the domain or x values is x is greater than positive 1. So that means it cannot be positive 1 nor numbers to the left of positive 1. That includes numbers between 0 and 1, 0 and all negative numbers. So that's why in a table of values, we do not have there a positive 1 as x value. Then for the range is still, it is the set of real numbers because y values of the points consisting these lines or curves can take negative number, 0 or positive. Then the x-intercept is not just 1 always. It is solved by equating y to 0 and solving for x. So that's the usual way of solving for the x-intercept. Assign 0 or substitute 0 to y and then solve for x. That will be the x-intercept. So just that also apply to the next two equations. Substitute 0 to y and solve for the x value. That will be the x-intercept value. And if c is less than 0, meaning if c is negative, there is a y-intercept. In which equation is c negative? In this equation, with the purple curve, because c here is negative 1. If c is negative, according to this statement, there is a y-intercept. So that's why the curve intersects the y-axis. It intersects the y-axis at 0. So the y-intercept of this curve is 0. But since c for the blue curve and gray curve is not less than 0, because this is 0, exactly 0, and this is positive, that's why we do not have y-intercept for these equations or these graphs. Next, the vertical asymptote is x equals c. So it depends also on the value of c. c here is negative 1, so the vertical asymptote is x equals negative 1. c here is 0, so the vertical asymptote is x equals 0, the line which coincides with the y-axis. And since c here is positive 1, then the vertical asymptote is x equals 1. That means the graph gets closer and closer to x equals 1, to this vertical line, but it will not intersect that line. And there is no horizontal asymptote for any of these equations or graphs. For the last example, example 6, sketch the graphs of f of x equals logarithm of x to the base 2, f of x equals logarithm of x to the base 2 plus 1. So this consisted of two terms. And f of x equals logarithm of x to the base 2, that's the first term, minus 1, the second term. Describe their properties. They have the same a values, all are 1. They have the same b values, all are 2. Same x values, all are 0, 0, 0. But they differ in y, in b values. b here is the second term 0, so that's b. b here is positive 1 and b here is negative 1. Okay, we'll sketch their graphs in a Cartesian plane by preparing first the table of values for each, and then we'll describe their properties. Again, this is the table of values for f of x equals logarithm of x to the base 2. We've been encountering this since from example 1. And then for the second function, f of x equals logarithm of x to the base 2 plus 1. This is the table of values. We use the same x values. And this is for the third, when b is negative 1. Okay, in the next slide, we will sketch their graphs. So these are the graphs of the three functions in example 6. The blue, again, is for f of x equals logarithm of x to the base 2, that is when b is 0. The purple curve is when b is positive 1. And the gray curve is for the equation where b is negative 1. Let us describe their properties. Given f of x equals logarithm of x to the base b plus d, that's another term, the graph is always increasing. So that is why from left to right, each of the graphs involved here increase or is increasing, or it goes up from left to right. Next property, the graph is shifted downward by d units if d is negative and upward if d is positive. So that is why from the blue curve or cyan curve, it is shifted upward if d is positive, because d here is positive 1. So it is shifted every point is shifted 1 unit upward. So from blue to purple, it is shifted upward when d is positive. And when d is negative, it can be clearly seen here that the graph is shifted downward, again by 1 unit because the value of d is 1. The domain is the set of positive real numbers. All points have positive x values for each equation or graph. Then the range is the set of real numbers because the y values can be negative, 0, or positive. Then the x-intercept is solved by equating y to 0 and solving for x. So again, the usual way of solving for the x-intercept, assign 0 to y or substitute 0 to y, 0 to this y, and then solve for the corresponding x value. That is true to every equation here. Next, there is no y-intercept. We can see that while the x-intercept differ, the y-intercept or each of the graph has no y-intercept because they do not touch the y-axis. If we zoom this in, we will be able to see clearly that they do not touch the y-axis. They just get closer and closer to the y-axis. Then the vertical asymptote is x equals 0. Again, because they get closer and closer to the y-axis. And the equation of that line is x equals 0. So that acts as the vertical asymptote. And again, there is no horizontal asymptote.
Again, given f of x equals a times logarithm of x minus c to the base b plus d, a is responsible for the shrinking or stretching of the graph. B determines whether the graph is increasing or decreasing. C tells about the movement of the graph to the left or to the right. And D says the shape of the graph upward or downward. I suppose by now, you know logarithmic functions a lot better than before we tackled this lesson. Far, far better than before. You know how they behave in the Cartesian plane and how they look like. I'm pretty sure you'll recognize logarithmic functions when you meet them anywhere. Until next time.